Ciao friends. Today I was working on the dynamic segmentation pattern and I was curious to see how the dynamic segmentation pattern works with the new feature of composite model. I was kind of surprised because performance was awful, so I needed to optimize it. And the video shows the entire process of optimization. But this video is not just about optimizations, because in the process of optimizing the code, I started thinking at what new skills we need to acquire in order to optimize code for composite models. And what I discovered is that we need to learn new skills, we need to learn new techniques, we need to acquire new knowledge in order to make composite model work the right way. And this is the important message that I advance you now and I will go through at the end. If you already started learning how to optimize DAX code, then this is good. You will need to acquire new knowledge and it's a natural process. But if you have not yet already started to learn how the Vertipack engine works, how the DAX engine solves a query, then the moment to start learning it is now, because composite models increase the power and the complexity of your solutions. So if you do not start now, you will need to optimize composite models, but you will not have the required skills in order to do that. So you start with a strong technical debt that at some point you will need to pay. It's much better to pay it in advance and start with the right foot. Now, that's enough for a talk. Let's start looking at the scenario and what I had to do in order to optimize the code. As I said, we are going to talk about the dynamic segmentation pattern. I already have a model that works as a single model, but I wanted to build a composite model on top of it. So let's start by looking at the scenario. I have in the remote model, I have a segmentation table that contains low, medium, high with minimum sales and maximum sales. And what I want to do is cluster my customers based on their sales amount. So if the sales of a customer is in the low cluster, then I will I will classify that customer as low and compute the sales of different clusters. This is exactly what I'm doing here. So the low line contains the sales of all the customers that bought between $0 and $10,000. Then between 10,000 and 100,000 they are medium, and high over $100,000. The model works just fine, and it's right now this is a live connection to a remote model. So I don't have access to the code. You see that if I go, for example, I look at segment sales, I cannot see the code. And if I look at the content, all the tables are blue, meaning that all the tables are stored on the remote server. That's it, everything is working fine. I have my segment table and it is super fast. If I filter Australia or Canada or China, you see that the numbers update very, very quickly. The thing is, I cannot just work with this model, because if I want to change the boundaries of the segments, then I cannot, because the model is stored elsewhere. That is why segmentation patterns are the perfect candidate in order to create composite models. If I can create the segmentation table in my local model, I will have the option of changing the boundaries and I will be able to do any kind of segmentation, keeping all the data stored in the remote server and only the segmentation table in my local model. So let's do that together. As you are going to see, we will have some bad surprises, but let's do that step by step. The first step is creating a new segment table that I will call the local segment table. I'm not going to type the code all the time because it's just too long. So I just copy and paste it from the model that is already working. So let me create a new table, paste the code, and I will call this table local segments. The code is the same that is working on the remote model. And now I have here my local segments table that contains all my data. Well, it's not showing anything right now. Why that? Let me go here. Okay, now it's showing better data. I have the segments, the sort, the minimum and maximum sales as a new calculated table. Next step is I need to prepare it the right way, so the segment need to be sorted by the segment sort. And finally, I need to copy this. I just make a copy of the remote segment and I call this the local segments table. Let me remove from here the segment and instead I place the local segment. Right now you see segment sales is not working because this is still the calculation that uses the remote table. But I need to just replace this measure with a new measure or just create a new measure. Again, I already have the code of the measure that is working. Let me copy and we comment it a bit. I go in local segments, build a new measure, and here is the code. Now let's analyze the code a bit. I first retrieve the minimum and maximum, so the boundaries from the segment table. These should no longer be coming from the segments, but instead from the local segments table. And let's also rename it as local segment sales. Then I need again to take from the local segment the maximum sales. Next step, I identify the customers that are in the segments. So I filter the customer. For each customer, I take the sales amount. Sales amount due to context transition is the sales of the current customer. I check if the customer is in the segment by checking that the sales amount is greater than the current minimum, which is the minimum sales, and the sales amount is less than the current maximum, which is the variable created earlier. If this variable is true, then I save the customer, meaning that the customer is in between the boundaries. Then customers in segment contains the customers of the current segment, and I finally compute the sales amount using customer in segment as a filter. This code is working on the server, so there is no reason it should not work here. Now I can get rid of the segment sales from here. Take my local segment sales. Let's format it as a decimal number while we are here. And finally, I can take my local segment sales and drop it here. Here is the first problem. Look at that. It's computing. And it goes on computing. It will take quite a while to return some number. The performance is really, really bad. I don't have a clear picture of how long it took, but it's definitely much slower than what happens in the remote segments table. We have them side by side. Let's filter, for example, a smaller country like Germany. You see that I already have the numbers, and the numbers came later here. Performance is much worse. So I need to investigate on that. I need to understand where the problem is. To do that, we need to first enable the performance analyzer, start recording, and refresh the visuals. Let's look at the details. This matrix is the remote segment table. It computed in 200 milliseconds. The one that is computing with the local table is running in 2 seconds. That is 10 times slower. What is the reason for that? We need to investigate a bit more. So let me copy the query. And you probably don't notice that, but right now, just the process of copying the query is extremely slow. It's taking a lot of time. We have no clear idea right now, but this is a signal that the query is really huge. So we are running a query that is so large that only the step of copying the query in the clipboard takes a lot of time. In the meantime, it finished, so I can now launch DAX Studio and analyze the query. DAX Studio open in the wrong place. Let me copy the query. Now, I just copied the query and you see that it doesn't look like a complex query. The reason is DAX Studio stripped off the most complex part of the query because the real query contains not only the DAX code but also all the direct queries which are really huge. But we will see them in a minute. Now, this is my query. Let me simplify it a bit before working on it. I want to take this filter and move it straight here to save some space. And then this top n, which is always present in all the queries, I don't want it. And I can just take this summarize and use it as the result. The order by 2 is not really relevant. Now I can format the code, and this is the measure that is being executed. It's just a summarize columns that summarizes by segment and segment sort for the sorting and computes the local segment sales for Germany. We can enable server timings and run it. We already know it's going to take a couple of seconds. Okay, it finished. Now we have a more precise measurements. It's 1.7 seconds. And we have the list of all the queries that have been executed. Let's save some space. We have a first query that retrieves the segment and the segment sort, another one that retrieves the minimum and maximum table sales, and then we have this query that retrieves summarize of customer by customer key, customer code, customer title, customer name. This query is retrieving the entire customer table where customers are living in Germany. And the next query, that is the worst one. Look at that. In the variable, we define this huge variable that contains, well, basically all the customer table. So the entire customer table had to be moved back and forth between the two engines because of the way we wrote the query. Now we are going to optimize the code, but before doing that, I want to take a measurement of the query running on the entire dataset, because right now I'm filtering only Germany, and I want to have a baseline of the entire query. We know it's going to take a while, so let me copy this query. I just create a new window in DAX Studio, enable server timings, and I remove this filter on Germany. The reason is I only want to gather the server timings, and because it's taking a while, I let it run, and in the meantime, I optimize the code. In order to optimize the code, we need to find the definition of the measure, which is in our local segment. It's here in local segment. Let's add the definition of the code. Format the code. So my measure is first retrieving the minimum local segment mean sales. Local segment is in the local model, so this is happening on my local model. The same is happening here, and I have my first problem here. I'm filtering customer. So this filter over the customer need to be executed on the remote machine, and the result needs to be returned on the local machine. And because I'm filtering customer, the entire customer table needs to be filtered on the server and returned to the client. This is the first query that we have seen that was retrieving all the customers. And then this calculator requires me to compute the sales amount using customers in segment as a filter. Now think about that. Customer in segment is a variable that is computed on the remote machine, and then it is sent back to the local machine, but then it needs to be sent again to the remote server in order to apply the filter. And this is the problem of my query. It takes a lot of time because of the size of the filter that we need to move back and forth between the two machines. So how can we optimize it? The thing is, we do not need to actually filter the entire customer table. We don't want the entire customer table. It is enough to filter the customer key. Customer key would be enough in order to apply a filter on the sales table. We do not want the customer name, the customer address, or the customer birth date. We just want the minimum set of columns that is needed to apply the filter. And customer key is the perfect candidate. So let's see how performance change if instead of filtering customer, I filter values of customer key. We start from 1.7 seconds, that is our baseline. Let me run it. And now it goes in 130 milliseconds. That is around 10 times faster. Not only it's faster, but if we look at the queries, you see that the first query only retrieves the customer key as expected, and the second query generates a variable that contains a lot of numbers, but it only contains the customer keys, so its size is much smaller than earlier. Can we do anything better than that? Well, we are iterating the customer key. If not all the customers bought something, sales customer key will have a smaller number of values. So we might have better performance by using sales customer key instead of using customer key. Let's give that a try. Instead of iterating over values of customer key, I can use sales customer key. It's the same column, it just has fewer values. We have 130 milliseconds. We run it again, and that goes in 90 milliseconds, 89 milliseconds, so a bit better. By reducing the size of the filter, we actually reduce by a lot the time needed to execute the query. In the meantime, my query here finished, and we have our baseline for the full dataset. Remember that we were filtering only Germany, whereas this query is filtering nothing. And the entire query on the entire dataset runs in 12 seconds. That's definitely bad. Let's see how our best measure works over the entire dataset. I need to copy the entire define statement, put it here at the beginning, and I can run it again. 12 seconds is where we start from, and it goes in half a second now that we optimize the code. That is 24 times faster, which is really good. Now that I have the code that works better, well, the only thing is that I need to change values here. So we can get rid of DAX Studio, go in our local segment measure, get rid of performance analyzer, and instead of filtering customers, we filter values of sales customer key. Everything else is the same. And now if I change my filter, I go to Australia, you see that performance is way better. Now this is the kind of performance that I would expect from a regular Power BI model. Let's draw some conclusion up to this point. As I said, this is not a video about optimizations. I'm totally not sure that this version of the code is the fastest possible. It might be that in the process of learning, we find better ways of expressing the same code. We are still learning. We are at the beginning of the evolution of Power BI. What I wanted to tell you in this video is that the skills, the things that you need to look at while optimizing composite models are different than the details that you look when you only optimize a regular model. But they are not only different, they are on top of the details that you use when you work with a single model. With a single model, you try to push the entire calculation to the storage engine, or you balance storage engine and formula engine the right way in order to have good performance. With composite models, on top of that, you also need to worry about the size of the filters and the queries that need to go back and forth between the remote machine and the local machine. If you do not pay attention to also these details, then you will have problems. And you will wrongly conclude that composite models do not work well, whereas the problem is only that the code is not written the right way. So that's why my suggestion is if you want to work with composite models, you will need to learn the details about how to optimize the DAX code. And the moment when to do that is now. Do not accumulate a technical debt that will create you issues later. Start learning now the details of the Vertipack engine with normal models, and then on top of this solid understanding, build the knowledge that is needed in order to learn how to optimize composite models. Enjoy, guys!